This is an introductory lesson on limits, and it's based off the information we saw in our first video. So let me remind you that if the limit as x approaches c from the left of f of x is the same as the limit as x approaches c from the right of f of x, and it equals some number L, then the limit as x approaches c of f of x exists, and that limit, the limit as x approaches c of f of x, equals that value of L. So this is the first concept I want to get down for us, that the limit from the left, if it equals limit to the right, from the right, then the limit exists and it is that value. Now this limit has to be a finite number. This limit cannot be infinity. We don't say that an infinite limit exists, but it has a special sort of significance for us. So let's take a look at another example. Let's look at the limit as x goes to 0 of the square root of 4 plus x minus 2 over x. We want to see what happens as we approach from the left, what happens as we approach from the right. Are they the same? If so, the limit exists. If not, the limit doesn't exist. Again, this is not a proof, this is exploration. So we're going to choose numbers to the left of 0. So just for the sake of discussion, I'll call that g of x is the square root of 4 plus x minus 2 over x. So we'll put x here, we'll put g of x here. I want to choose values to the left of 0, like negative 0.1, negative 0.01, negative 0.001. If you want to just change it up a little bit, 0.00005, who knows. So we're going to plug in various values and see what we get out for that function. But I'm going to use my graphing calculator to help me do the analysis here. So let me go ahead and pull that graphing calculator up. And we're going to go to our y equals button. If you're not clear, it's up here, y equals. And I want square root of 4 plus x minus 2 over x. Be careful with your parentheses. Numerators in parentheses. Whoops. We'll try it again. Numerators in parentheses. Square root, second here, square root of 4 plus x. Then I have to subtract 2. Again, watch your order of operations. Make sure that's not under the radical. Square root of 4 plus x minus 2 divided by x. We want to choose numbers that are close to 0, like negative 0.1, etc. I'm going to go to second table set, make sure it's on ask. The numbers that are there before I will just erase out. Clear, can I clear these? That's not letting me do that. So I just type over them. Negative 0.1 is here. Negative button down here, remember, 0.01. Negative 0.001. It says 0.25, but is it really 0.25? It's really 0.25001567. It's rounding it off. And then the last one I put on my table here is negative 0.4 zeros, 1, 2, 3, 4 zeros, and then a 5. What did that give me? Again, it says 0.25, but what is it really? It's really 0.250000782. The one above it really is, again, 0.25001567, etc. The one above that is about 0.2502. The one above that is about 0.2516. So looking at our table now, approaching 0 from the left, what are these function values approaching? Again, this last one is 250000782. awfully close to 0.25. So it sure appears that the limit as x approaches 0 from the left of this function, which I've gone ahead and called g of x, looks like it's 0.25. But that's not enough to prove that the limit exists. I've also got to show it from the right. So what is that going to be? Let's go with 0.1, 0.01, maybe 0.00008, something like that, just to give us a feel for a few more numbers and how the function is behaving with numbers to the right of 0. So 0.1, 0.01, 0.00008. What do we have? 2485, 2485, 0.2498. And then the last one is really 24999,875. Okay, so looking at our table, the numbers from the right also, as the x values get closer to 0, the values of the function also seem to be getting closer to 0.25. So it appears, again, not a proof, it appears that the limit as x goes to 0 from the right of g of x is also 0.25. So since they are the same, the limit as x approaches 0 of g of x exists. What are we going to say about that? We're going to say the limit as x approaches 0 of g of x equals that common left and right limit of 0.25 or 1/4. Now, we're going to need to talk about how to prove that. We're going to need to use some algebraic strategies to get there. But I want to make sure we are solid on the basic concepts that we're working with here first. Okay, let's go do another problem. Let's look at the limit as x approaches 2 of 5 over x minus 2. So that if we're going to determine if there's a limit, we have to approach 2 from the left, we have to approach 2 from the right. Approaching 2 from the left, 1.9, 1.99, 1.999 is a good choice. Approaching it from the right, 2.1, 2.01, 2.001 maybe. Those are some values for us. And for the sake of discussion, let's call f of x 5 over x minus 2. So here is x and here is f of x. You want to see what are the values of the function as the x values get closer to 2, what do the f of x values get closer to? That's our question. So let's go back here. I'm going to make it automatic just so I can clear that out first. Second table, and then we're going to change it back to second table set ask. Now my table is clear. Okay. I'm going to go ahead and plug in 5 divided by x minus 2. Y equals button, clear that. 5 divided by parentheses x minus 2. Whoops. And we are going to be approaching numbers closer and closer to 2 from the left. So let's go to our table. We're going to make it ask, indeed. 1.9 gives us negative 50. 1.99 gives us negative 500. 1.999 gives us negative 5,000. Well, that is absolutely not stabilizing. As we get closer and closer to 2, the limit as x approaches 2 from the left of f of x, it doesn't exist. It's not a real number. It is tending towards negative infinity. So some authors say it actually equals negative infinity. I can live with that if you recognize that if a limit is infinity or negative infinity, that limit doesn't exist. I want to make sure you're clear with that. But this is a common notational convention. Now, how about if I approach it from the right? So first of all, if the limit is approached from the left doesn't exist, then that limit doesn't exist. I know that for sure. But we'll see if maybe we can get a feel for what's happening with these infinities. Let's go back and plug in the numbers to the right of 2. 2.1 goes to 50. 2.01 goes to 500. 2.001 goes to 5,000 again. As we approach from the right, it's going to positive infinity this time. So the limit as x approaches 2 from the right of f of x is positive infinity. Also, it doesn't exist. Limit as x approaches 2 from the right of f of x does not exist. Well, I mean, they're different too. You can't even say it equals infinity or negative infinity. So that's our conclusion. The limit as x approaches 2 of that function of 5 over x minus 2 does not exist. And it's probably a little bit helpful for us to look at the graph of that function. Okay, let's take a look. Maybe we'll go to Desmos to look at the graph. So we're going to take a look at f of x equals 5 over x minus 2. And you can see approaching it from the left, as the x values get closer and closer to 2 from the left, the y values, the function values go to negative infinity. As we approach 2 from the right, the function values go to positive infinity. It's broken. The graph is not continuous. So that's important for us to see as well. Let's take a look at one more example as we look at tables to help us understand the behavior of limits. Let's do a trig example. Let's look at the limit as x goes to 0. Sine x over x. So I want to plug in values. I'm just going to give you a reminder in this course, whenever we use trig, make sure you are in radian mode. It's very important. So I'm going to choose values to the left of 0 and to the right of 0. For the sake of our discussion, let's say it's g of x is sine x over x. So we've got x here, we have g of x here. To the left of 0, negative 0.1, negative 0.01, negative 0.0005 maybe. To the right of 0, 0.1, 0.01, 0.00002, who knows. Just picking numbers to the left of 0, to the right of 0, getting closer and closer and closer to 0 to see how this is behaving. But as I mentioned, you must be in radian mode. So I'm going to check that. We're going to go to mode here on this calculator if I can find it. There it is, right down. My mode is right there. And we're in radian mode, so that's good. And I want sine x divided by x. So y equals, we'll clear that from our previous problem, parentheses sine x in radian mode divided by x. And I want to fill in elements of my table. So I usually go automatic first, look at the table, then I go to ask, so it'll clear out all the other values. Not that it's necessary, you can always type over them as you've seen. All right, so as I go to the table, negative 0.1, negative button down here, negative 0.1, 9983, interesting, negative 0.01. It says it's 1, is it really 1? It's really 0.99998. 333 and change. And the one above is really 99833. And the negative 0.0005, you can kind of see a trend already. Negative 0.0005. gives me, again, a number awfully close to 1, which is a whole bunch of 9s, 0.9999958. How many 9s? 1, 2, 3, 4, 5, 6, 7 9s. And then something else. So certainly, as I approach 0 from the left, the limit as x approaches 0 from the left of sine x over x sure looks like it's 1. Now, we hope we're going to get a similar number as we approach 0 from the right. So let's plug those numbers in the graphing calculator. So 0.1, 0.01, 0 point, and a whole bunch of zeros. 1, 2, 3, 4, 5, 2. And certainly those numbers are getting closer and closer to 1. So 9983, 0.999983. And the last one is going to be a whole stinking bunch of 9s. 1, 2, 3, 4, 5, 6, 7, 8. 4, 5, 6, 7, 8, 9. 12 9s. And then 3, 5. So it's not quite 1, but it is awfully close. So the limit as x approaches 0 from the right of sine x over x. Sure looks like that's 1. So they are the same. The limit from the left and the limit from the right are the same. So what is our conclusion? Limit as x goes to 0 of sine x over x exists. First off, it's not infinity, and the limit from the left and the limit from the right exists. They're the same. And the conclusion is the limit as x approaches 0. Sine x over x equals 1.